and show you guys how to, Jason, do you have a question? All right, let me know if you guys have questions, and also try not to put anything on chat. Just communicate with me using your audio. That way it's much faster and I can answer your question quickly. So we're going to be taking our quizzes and exams on Blackboard for the next one. So I'm going to show you how to use Blackboard exam environment. That way you're familiar with it before you take your quiz or test. So here's what you have to do. So once you come to Blackboard and you're under course, this is how it's going to look like. Well, not really like this, right? But you're still able to see the left side where you have the contents. And if you look down, there is last component that says exams and quizzes. If you click on that, there is a sample test, or you can call it a quiz. It's pretty short. There is a sample test that should help you or prepare you for our next quiz. Okay, so this is open until Friday. Usually that's not going to be the case because you only have access for 20 minutes, or if it's an exam for an hour. But because it's a sample, this will be open until Friday. That way you can work on it whenever you want, whenever time is convenient for you. So you would click on the test, read the instruction, and start the test. Now, the good thing about this test is that once you start the test, you have to finish it. You can't come back to it. Okay, so it forces you to finish the test in one sitting. Another thing you want to keep in mind that it's a multiple choice test. So once you pick an answer, make sure you save and move on to the next one, but don't pick something that you're not comfortable with. You can change your answer. And also, once you pass on to the next question, you can go back to your previous question. So there's a lot of good thing about taking a test on Blackboard because it forces you, keep you on track of how to maintain your time, be very careful with your answers. So take the sample test, try it out, and then our next class, which will be on the 14th, we will have our second quiz on Blackboard. So that's the update I have. So any questions on this? Make sense, guys?
No more quizzes on WebAssign?
Well, we might, but the next quiz will be on Blackboard.
I have a question. Well, I have two. The sample quiz doesn't like count towards our grade, right?
No, so this one doesn't count. This is just prepping you how to use Blackboard test taking.
Oh, and also on WebAssign, when we had to put certain things such as like an infinity sign, in Blackboard, does it give you like any options to do that? Because like with my computer, I can't put it.
So you don't have to worry about any of those for Blackboard because it's a multiple choice. So the answers are already written for you in choices. You just have to pick the right one.
Okay, thank you.
Yeah. So another good thing is you don't have to worry about typing math symbol in Blackboard because I'm trying to make the test multiple choice. That way you don't have to learn coding. I think it could be a messy way of writing in Blackboard. So I'll make that not an option. So it'll be all multiple choice for now. Any other questions?
And the homework is still on WebAssign?
Yep. So the homework's still on WebAssign. It's just the next quiz will be on Blackboard. And our next quiz will be on the 14th. So I'm going to start writing it on my OneNote. That way we have it as a reference and come back to it next time. All right, so let's go ahead and start writing. Did someone have a question? Yeah, I'm going to write that down right now. All right, so let's write everything down. That way you have it in your notes. So our next quiz is on Blackboard. Okay, so make sure you take the sample. That way you're familiar with it when the actual quiz takes place. So next quiz is going to be quiz number 2. So this is quiz number 2. Well, maybe I should just write it here. Number 2, right? And this will have materials from P3 and P4. Okay, so you guys had P3 on the other quiz, but no, you guys didn't. So P3 and P4 will be on the next quiz, and you will have about 3 to 5 questions and 20 minutes. Okay, am I missing anything else? Any questions, guys? And oh, so I didn't write the date, right? So this is going to be on September 14th. Okay. Yeah. Yeah, go ahead, do that. Yeah, no problem. All right. Any other concern, questions? Yeah, it's okay. No parts. Yeah. Yeah, so it's just question, you pick an answer. So it'll be very similar to the sample test. You'll be trying it out, but of course it's going to be more relevant to what we're doing right now. So don't worry about the sample test getting everything right, because it doesn't count towards your grade. So for this, so I want you to try out the sample test that's available to you right now. And this is available until Friday. Okay, so after Friday 11:59 p.m. it's gonna close up, so you won't be able to take the test anymore. And just keep in mind, it's not counted. Okay, so it's not counted towards your grade. So don't panic. You can start whenever you want. You have 20 minutes to finish the test. It forces you to finish the test. So once you leave, you can't come back to it. So make sure you do it in one sitting. So same idea will apply to our actual quiz and exam. And you can't even backtrack questions. So just keep that in mind as well. Okay, so just get familiar with testing environment in Blackboard. That's the purpose of that test. Okay. Okay, any other questions? All right, okay, we'll go ahead and start. So again, let me know if you guys have any questions. Use your audio to communicate. It's just so much faster to answer your questions or concern and hear them. So I'm going to go ahead and start with P4. So P3, we talked about exponents, and you guys had homework problem that was due this weekend. So hopefully you guys had some good time working on those questions. So just like Azza said, they're not much, they're very little. So if you want more questions, do the textbook questions. There are plenty of them. And if you still want more, look at the past final. Maybe it's helpful, I don't know, but see what helps you. But usually the homework and textbook questions should be enough for you to prep you for these materials. Okay, so try to do that as well. Okay, so I'm going to go ahead and start with P4. P4, we're going to study rational exponents. So rational means fractional, right? So the exponents that are fraction, exponents, and radicals. So the same laws we had for exponents, where the exponent is an integer, you can also use it for rational exponents. But I'll write down the properties again, that way you have them written down for you one more time and become familiar with them. So Well, what's a rational exponent, right? So think of it this way. So here's a formal definition. So if you have, actually, before I give you the definition, let me give you an example. So that way it makes a little bit more sense. So think of something like this. So say you want to evaluate the following. You want to take a square root of 36. That's a radical, right? Now, usually for a square root, we don't write the 2 in there. It's understood it's a square root. And what we do, we can rewrite this as an exponential form. So we write it as 36 to the power 1/2. Right? So that's the exponential form of a square root. And if I want to evaluate, well, I simply ask myself, what number multiply itself 2 times to give us 36? That's kind of how you evaluate square roots. So what's the magical number? 6, right? Because you can see that if you do 6 times 6, you get 36. In other words, if I do 6 square, I should get 36. So you can see how the square and the square root are related, right? So they're just doing the opposite operations. Think of another one. What if you want to evaluate, say, cube root of 125? Now, once you're beyond a square root, you have to start writing the index right here. So because it's a cube root, I wrote the 3 there. And if you want to write this as an exponential form, you can say this is 125 to the power 1/3. So now we ask ourselves, what number multiply itself 3 times to give us 125? What do you guys think? 5, right? Now let's check. So if I do 5 times 5 times 5, right? Voila, 125. Right? Check. And that's pretty much the idea with fractional power, where we can rewrite them as a radical. Now here's the definition. So here's a formal definition. So this is a definition of nth root. We're calling nth just to generalize the exponent. So if I have, say, nth root of a to the m, right? M is also an exponent. This can be written as a to the power m over n. Okay, and the left side, you can also write it this way: nth root of a to the power m. So the exponent m, you can be inside the radical or you can go outside the radical. Any of these are fine. So that's the formal definition of an nth root. Also, if the power of m is not just 1. So for example, the ones that we just did, our m happens to be 1. Right? So we just wrote 1 over 3, 1 over 2 as the exponent. Now, for example, if I want to, so I have an example right here. So suppose, no reason. I just want that to be next to this one, so that both of these can be written as exponential form as m over n. Okay. Alright, so let's look at this problem. We want to write the following in exponential form. So all you're doing is identifying what is your m and what is your n and rewriting in a fractional form. So what's m and what's n in this problem? Right. So what will be the exponential form for this one? Not 9. The base A is 2, right? Oh, it's okay. Right, so it's 2 to the power 2 over 9. So hopefully that's clear, right? Can you guys see that? Right, so the exponent for the base 2 is m, and the index on the radical is your n, which is 2. And you can think of the index is always going bottom of the fraction. Okay, so just keep that in mind. So any questions on this? This is very important. Make sure you understand this. Okay, now let's look at another. Radical. Okay, so think of something like this. So let me give you an example to answer your question. So if I ask you to say evaluate square root of, let's say, 40, okay? Well, here are your m and n. Well, you can think there is a 1 there and there is a 2 here. Usually if it's a square root, we don't write it. And if it's a power 1, we still don't write it, right? Or else our math textbook will be really thick. So you can write this as 40 to the power 1 over 2, right? In exponential form. But again, that's not needed. It's just if the question asks, then you want to. So what you want to do is you want to focus on this and you want to evaluate. Now, to evaluate, what it really means is you ask yourself what number multiply itself 2 times because it's a square root to give you 40, right? Now, if you look down all the perfect squares, right, we have 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on, right? Keep going. These are the perfect square. None of them gives you 40. But we can find something that is a perfect square. It multiplies with another number to give us 40. So what do we do? Tell me one more time. Well, 9 and 5, that's 45, right? 4 and 10, right? So right, so what do? We rewrite. So we rewrite it this way. This is 4 and 10. Well, so I'm going to give you a property later on which allows us to do this. So for now, just follow through. So what we do now is we split it into 2 radicals. That's one of the property for radicals. So we can do the square root of 4 times square root of 10. And then, well, now this piece, square root of 4, that's a perfect square, right? That's on our list right here. So what's the square root of 4? 2. And then square root of 10, well, it doesn't have any, right? Because it's 5 times 2 and then 10 times 1. So none of it simplifies. So that's the simplification for square root of 40. So really, you're asking yourself, is there a perfect square hidden, or is the number itself a perfect square? Now, if you look up, probably in the textbook, they have a list of perfect square, so you should know up to 15. I think up to 15 is a good number, even 16 too. But really up to you, how much do you want to know? You could go up to 20 if you want to. But after 15, you should have memorized, right? You should know the square root of 144 is 12. So probably few should be very convenient for you to evaluate. Now, let me give you the properties, and then we'll do more examples. But pretty much, that's how we deal with square roots and radicals. You can rewrite them as a power, a fractional power. Okay. So here are the properties of nth root. Okay. So think of it this way. So say you have nth root of a times b, which we did just on this example, right? You can think of a is 4 and b is 10. You're allowed to separate the radicals. Well, why are we allowed to do that? Think of it this way. If I rewrite this as an exponential form, I have ab to the power 1 over n, right? Because my m is 1 and the index of the radical is n. And then by laws of exponent, because I have multiplication between a and b, I can distribute the exponent. So this is a to the power n times b to the power n. And then you convert it back to radical form. So this will be nth root of a times nth root of b. So that's the property we used for this problem. Okay, so where this was your a and this was your b. So that's one of the property you can use. Again, combine with exponential laws. Second property is for division. If you have nth root of a over b, assuming b is not 0, okay? So I can split it into two radicals. So this would be nth root of a over nth root of b, okay? And then we have the third one. If I have nth root of m root of a, right? So this looks really creepy, but we can rewrite it as an exponent and then probably simplify it. Well, so to get the rule for this one, this is what I'm going to do. I'm going to rewrite the radical that's inside first. So keep the nth root outside. How do I rewrite m root of a as an exponent form? So who can tell me what's mth root of a? Right. Good. And now we rewrite the nth root. So that would be what? So we keep the inside, a to the 1 over m, and rewrite the nth root, that's 1 over n. Okay, let me know if you guys follow. Make sense? Well, now, from exponents rule, what do we do with these exponents? Multiply them, right? So we have a to the power 1 over 1, 1 times 1, and then n times n. Oh, times n. Right? And then if you rewrite this back as a radical, what will be the radical form for this exponent? Who can tell me? Can you guys guess? Uh-huh. Absolutely. There you go. So your m and n becomes the index. So you're taking m times nth root of a. So pretty much you're allowed to do that. So if you're given this, that's how we rewrite it. Okay. So any questions on this? Okay, hopefully this makes sense. Now, one more, last one. What if you have nth root of a to the n? How do we simplify that? Absolutely. So right, again, you can write it as an exponential form. You have a to the power n over n, right? Because now the m that we wrote before is now n. So same exponent, n over n is just 1, so that will simply be a. Now there is a little confusion to this if a happens to be negative. So if a is negative and n is even, you want to make sure you put an absolute value. So this rule it's something to be keeping mindful of, but it's not something we use pretty often. So just rewrite this as a remark. Okay, so if a is less than 0 and n is even, so this is just a remark, then we have the following. So n to the a to the n, that's going to be the absolute value of a. Okay, so keep that in mind if a is negative and n is even power. Okay, let me give you an example to illustrate this a tiny bit. So suppose you want to evaluate something like this. Say square root of negative 2, let's use negative 3 squared. So I'm looking at something like this. What will be the result of this? Which would be 3. Right. But if it's an odd power, then we don't really have to think twice. You can just go ahead and say cube root of 5 cubed. Or you can just simply use rule number 4 without the remark. Cancel out the 3 and the exponents and the radical. You have simply 5. Okay. So something very tiny to be careful on. It comes sometimes in examples. Alright, so now that we wrote down the properties, we're ready to do some examples. Any questions on any of these properties? So again, let me know if you guys have questions. So I have a couple of it. So go ahead if you have your hand up. Sure. Let's go over the remark again. So what this really is saying is, so let me process another example. So let's say you're looking at something like this. Fourth root of negative 3, well, let's use different number. Negative 7 to the 4. Now say you didn't remember the remark and you say, aha, I cancel them, negative 7. Well, you're not really right. Why not? Because, so here's the explanation. This is fourth root of negative 7 to the 4. Well, if you were to do the exponent first, that's simply fourth root of negative 7 times negative 7 times negative 7 times negative 7. You have even numbers of negative sign. What does that mean, Asa? You see it? Absolutely. So you see, So just to finish this further, the 4 negatives, they cancel out, right? Because the even powers. So you really have is 7 times 7 times 7 times 7. And then if you were to group it as an exponent, you have fourth root of 7 to the 4th. Well, now sure, 7. But you kind of have to think about it before you claim that's your answer. Okay, so whereas if you were to claim that as an answer, makes sense, right? Right. Yeah. Yeah, no problem. So, all right, so hopefully you guys are okay. Let me know if you guys have questions. Okay. All right, so here are a few examples. So let's work on these. Evaluate. So let's call this example 1. And I'm going to give you just a couple more.
2. So for the second one, you want to simplify and combine. So I'll give you guys about 3 minutes to work on these. The first 3 should be very quick, and the last one might require a little bit more time, so 3 minutes should do. Alright, so let's go ahead and start. So can someone tell me the answer for A? Nice. Alright, so that's 8. Now you can check your answer. Because it's a square root, that means 8 times 8 should give us 64. Check. Now can someone tell me the answer for number 1B? -4. Okay, let's check, right? -4 times -4 times -4, right? It's a cube root. That means you should be multiplying this number 3 times. So that's 64 negative. Check. And can someone tell me the last one? C. Okay, let's check, right? So -2, -2, -2, -2, and -2. And that should be -32, right? So fifth root, meaning you're looking for a number multiplying itself 5 times to give you that number. Alright, looking good. Now let's do the last one together. So for this one, we want to simplify as much as we can. 32 and 18, none of them are perfect squares, but they have a hidden perfect square. So we're going to use the properties to simplify. So how do we simplify square root of 32? Okay, so we can do 16 times 2. And what about square root of 18? Right. Now we use the properties that we wrote down earlier to separate these radicals. So we have square root of 16 times square root of 2 plus square root of 3. No, sorry. I'm moving ahead, right? But that was wrong anyway. Okay, back to where I was. So I use the property to separate the radicals. Now what do I do? Help me out, guys. Mm-hmm. Mm-hmm. Good. So you're almost done. Now you see how they both have same radical? Now I can do this, right? I can pull out the radical 2 and rewrite their coefficients, 4 and 3. We're going to learn that in P5. So for now, it's just a practice, I guess. You're allowed to add them if they have same radican, okay? So then 4 plus 3, or subtract them. That would be 7 radical 2. So that would be the final answer. So any questions on this problem? So for cubes, like no 2, 3, 4, 5 is a good one too. Beyond 5, I will just play around with it. And then for fifth root, no 2, 3. Beyond that, you're probably just gonna have to play around with it because the numbers wouldn't be that big. Trust me. Okay, hopefully that answers your question. Let me know. Uh-huh. Right. There are other ways playing around. So what I would do, I would just go down the list. Like start with 1. Well, 1 goes in everything, doesn't help. 2, 3, 4. Just go down the list, and you'll get there. So don't just jump around like maybe 3, maybe 7, maybe 5. Just go down the list, and it should be always around 2, 3, 4, 5. Right. You you can also do that too, right? So there's so many techniques. Absolutely. Yep, there you go. So you guys have other techniques. Again, doing homework would be another way, right? Once you do homework, you become familiar with these numbers, and then they just click on you very fast. So error and trial, right? See which way it works. Okay, I have a couple more examples for you to work on. So here's one. So let's call this one example 3. And just one more. So let's do 3 and 4. So I'll give you guys 2 minutes to work on these, and then we'll start. small ice, milk and caramel. Thanks. Alright. Are you guys ready? Okay. How's it going, guys? Ready? Okay. Can you guys hear me? Hello? Hello? Are you guys there? Okay. Still working on it. Okay. So let me give you another minute and then we'll start. So just checking. All right. So let's go ahead and start. Hopefully you guys had enough time to finish these. So for the first one, we want to evaluate square root of 12 and square root of 24. So again, it's a square root, so we're looking for a number multiplying itself twice to give us either 12 or 24, or we're looking for something that's hidden and it multiplies some other number. So if you're familiar with square roots, you will know 12 is not a perfect square, right? So if you just go down the list and just try 1 times 1, 2 times 2, 3 times 3, 4 times 4, you see you already went to 16, so you don't need to go down anymore, right? And if you're going to test out 24, so 16, let's go one more time. 5 times 5, that's 25. So now you went beyond 24 and you still haven't found it. So now you start telling yourself, maybe there is something hidden. They're not perfect squares. So let's work on 12. Can we rewrite 12 as a perfect square and a non-perfect square? So we can do 4 and 3. So because 3 times 4 is 12, and 4 is a perfect square, so it can come out of the radical. Great. Now let's move on to 24. How can I rewrite square root of 24? So again, I can do 6 and 4. Well, that's pretty nice, right? Now let's make these come out, right? So now square root of 4 can come out as a 2, and you're still left with square root of 3. And then for the second one, square root of 4 will come out as a 2, and you're still left with square root of 6. Now again, using the properties, I can group back square root of 3 and square root of 6. So I have 2 times 2, that's 4, and then we have 3 times 6 inside the square root. Well, now let's multiply these out. So 6 times 3, that's 18. Well, now you ask yourself, can 18 be simplified a little bit more? What do you guys think? Yeah, right? So we can take it more. Now let's simplify the last thing. Square root of 9 will come out as a 3, so that's 4 times 3, and square root of 2 stay inside, and that gives us 12 square root of 2. And again, square root of 2 doesn't simplify, so we have our answer. So we took longer approach, right? But we broke each numbers down with simple square roots, so that's the purpose. Any questions on something like this? Okay, now you could have done it differently. You could have also taken from here, right? Or you see how you have a square root of all of these numbers? What I can do, I can multiply the square root of 4 and square root of 4. So that gives me square root of 16. And then I have square root of 6 times 9, that's 6 times 3, that's 18. And we know square root of 16, that's 4. And then 18, you break it down one more time, 9 and 2. And then you're back to your answer, 12 square root of 2. So that could have been quicker, right? But again, it doesn't matter. Which way you take, you should get the same answer. Question? Alright, I guess that's a no. Well, let me know if you guys have any questions. Now, what about the next problem? Number 4. What did you guys get as your answer? So here you're simply using laws of exponent. 49, okay. How is it 49? Help us out. Oh, you did the hard way. We have a better way. So watch this. There you go. There you go. The laws of exponents. Same base, you add the exponents. It doesn't matter if your exponent is a fraction or a whole number, the rule still applies. Okay, so let's not expand 7th root of 7 square. That's huge, right? So if you add the exponents, 2 over 7 plus 12 over 7, we get 7 to the 14 over 7. Well, 14 over 7 is what? So 7 squared, right? That would be 49. So much faster doing it this way than expanding it, really. So hopefully you guys like it this way. How many of you tried this way? Okay. All right. Asa, did you expand? Right. You want to realize that they're the same base. If they weren't the same base, then we would probably have to take another approach. All right, great. Any questions? Okay, so let me give you another example similar to number 4. That way you get to practice a little bit more. So here I want you to again simplify. So say you want to do 10 to the 1/3. Okay, it's so hard to write fractional exponents. I want to try again. 1/3 times 10 to the 5/2. Okay, so hopefully you guys can read my exponent. So I want you to simplify 10 to the power 1/3 times 10 to the power 5/2. So take 1 minute, come up with the answer. Okay, what do you guys have? Let's hear some answers. Anyone wants to share? All right, Asa, let's go. Mm-hmm. 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 So all of this will be 10 to the power 17 over 6. Perfect. There you go. That's the idea. You want to put everything you learned from beginning and apply it now. And you're going to be keep applying them forever. Right? Everything connects. You should see those patterns that everything in mathematics connect. Any questions on this problem? Oh no, 1/3 and 5/2, that's easy, right? Yeah. Yeah. I wouldn't put big numbers. I mean, oh yeah. True. So there we go. We have another example on where the exponents are different fractions, and you're allowed to add them. Okay, I think I have couple. Okay, right. So this is also similar to what we just did. So try these two out, and then again we'll go over it together. So this is number 6. Simplify. All right, so let's start with 6a. What do you guys have for 6a? R, right? If there you go. So if you add the powers, right, you get 6 over 6, and we know 6 over 6 is 1. So it's r to the 1, and we often don't write the power 1, it's understood. So this is just r. Now, what do you guys have for part B? Uh, a to the 9 over 10. All right, looks good, right? Now for B, you have to do a little bit of work because the denominators are not same. So we're adding them. So we have 3/5 plus 3/10. So what's the LCD to add these fractions? 10. Right. So we multiply this one by 2 over 2 because it doesn't have 10 yet. And that will give you 9 over 10. So absolutely. So good job. Makes sense, right? Oh, okay. So I have a couple more right here. So this is our, let's say last example, and then we'll do something else. So for this one, we're again using the properties to simplify. So again, the direction is to simplify. So I'll help you out with this one. Now, every time you have something like this where it's a variable, not a number, you might want to rewrite, okay? So what I like to do is I like to rewrite. So let's do the first one. Let's call this one A. Let's call this one B. So for A, I'm going to rewrite the radical as a power. So I have x to the third, y to the sixth, to the power 1/3, right? Because it's a cube root. And then go ahead and distribute the exponent. So you have x to the third to the power 1/3 times y to the sixth to the power 1/3. And then we know by one of the properties of radicals, or exponent if you want to call it, we multiply the exponent. So for the first one, x to the third times 1/3, that's x to the 1, times y to the sixth times 1/3, it's y to the 2. And that's how you simplify them. That's one way to do it, okay? Another way is to just mentally think about, look at the powers, okay? So make an observation. This is to the third, this is to the sixth. And when you rewrite it as an exponential power, you're pretty much dividing the exponent by a power of 3, right? So what you're doing is you're taking x cubed, dividing it by 3. Well, that's just x, right? And then y to the sixth divided by 3, that's y to the 2. So you can also kind of do it mentally or show work as I have done for the first part. Any questions on this? Now try out the second part on your own, and then I will go over it with you. Okay, what do you guys have as your answer? Well, almost, right? So it's not just x times y. Yeah, right? So now if you think about it, you're dividing, so y has an exponent of 1, right? So if you divide each exponent by 3, first one for x, it'll just be x to the 1. But then y has a power of 1. If you divide by 3, it's just 1/3. It doesn't give you an integer value. So we can't really divide that. We don't want a decimal. So we keep it in this form. And that will be your final answer. Or if you want to write it in a radical form, so the x, and this is cube root of y. So you can also leave it like that. Does that make sense, guys? Okay. Let me give you another one. Try this one. So let's simplify 125 x to the 9 y to the 6 to the power 1/3.
Oh, thank you. I'm almost there. I have office hours today. Ah, okay. Okay, so let's start, right? So we're gonna go ahead and distribute the exponent. So we have 125 to the power 1/3 and x to the 9th to the power 1/3 and y to the 6th to the power 1/3.
right? That's what you should be thinking. Well, now here's the thing. If you want, you can rewrite these as a radical, but I will keep the exponent because I think I can function with exponents form. So someone tell me what's 125 to the 1/3 power? 5, right? Because you can think, well, that's a cube root of 125, and then just go down the ones. 1 times 1 times 1, 2 times 2 times 2, and so on, and you will see 5 will give it to you. Now what's x to the 9th to the power 1/3? So now here you're dividing the exponent by 3, so that would be x to the 3. Right, so you guys got it. Now what about the last one? Help me out. There you go. There you go. Any questions on this? Now what if the exponent doesn't divide evenly? What do we do in that case? So here's another example. So say you want to simplify the following. So for the previous two, the exponent happened to divide evenly, except for 7b, it didn't, so we kept it. But there's something else we can do. So observe this one. So say we have 25 x to the 4 and y to the 7 to the power 1/2. So I will let you think about it for a minute, and then I'll work it out with you. Okay, so let me go ahead and start. Now this could also be written to you this way. Square root of 25 x to the 4 y to the 7. Hopefully you guys agree, right? Well, now let's evaluate, right? So you can take any of these form and evaluate you throughout, but you have to choose which one you feel confident. So I'm going to go ahead and start with the exponent form. So we have 25 to the power 1/2. Well, x to the 4 to the power 1/2. Now, for y, you have to think about it just a little bit more. It's to the power 7. Well, if I do to the power 7 to the power 1/2, 7 doesn't divide too evenly. So what do you want to do? You want to split it up into an even power and an odd power. So I'm going to split up the power 7 as a 6 and a 1, because 6 plus 1 is 7. So make this observation. I'm going to rewrite y to the 6 and y, and that's to the power 1/2. So the reason I had to split it up, because it's to the power 7, and 7 is an odd power. 2 wouldn't divide 7 evenly. And now I can go ahead and distribute the second power, sorry, the half power. And so we have 25 to the power 1/2, x to the 4 to the 1/2, and now y to the 6 to the 1/2, and the last one y to the 1/2. That doesn't do much. And now we can divide them evenly. What's 25 to the power 1/2? Okay. What about the next term? Y to the 4th to the 1/2. Sorry, x to the 4th. And y to the 6th to the 1/2. Right. And then the last one remain as y to the 1/2. So we're just gonna say the square root of y. So this would be another way to simplify. Okay. So sometimes if you don't have even power, or if the power doesn't divide evenly, you want to split them up. Any questions on this? Yeah, go ahead. Mm-hmm. So y to the third, y to the fourth. So I could also do that, but then for this one, I would have to rewrite 2 and 1. Do you follow? Because 3, because 3 has a 2 in there, so that's, and this would divide evenly. So you go to the closest even number. All right. All right, so that's pretty much it for P4. And the last bit of P4 is to rationalize. So that's the last thing I'm going to cover. So rationalize denominator. Okay. So when we say rationalize, this word just means remove the radical. That's what that means. You want to remove the radical. So for example, so say I have 1 over square root of x, and I want to rationalize, right? So if I want to rationalize, well, I need to get rid of the radical from the bottom. Have you guys seen this before? Okay. So the person who said yes, Jamie or Alexis, tell us, how would you rationalize 1 over square root of x? So we have 1 over square root of x. We want to remove the radical. So go ahead if you have your hand up. No, it wouldn't be negative x. So all we want to do, good. So that's the idea. So the idea is you don't want to change the value of the expression. You just want to rewrite it in a way that it removes the radical from the denominator. So by multiplying by this magical number, well, that's really 1, right? Because square root of x over square root of x is 1. So you don't really change the meaning of the fraction. You're just modifying it and rewriting it. So now that we do that, what do we have as a result? So on top we have 1 times square root of x, that's square root of x. On the bottom we have square root of x times square root of x. Well, what does it become on the bottom? Just x, right? X, not 1, just x. Right, so what happened, you get this one right here. Sorry. You get just x. Well, why? Because if you rewrite these as an exponent, that's x to the 1/2 and x to the 1/2. Well, same base, we add the exponent, so that's just x to the 1. And that's what we got right here. And we were successfully able to remove the radical. So that's what we mean by rationalize. Any questions on this? Okay, so let me give you another example on this. So here's our second example. So say you want to rationalize 1 over fifth root of 3. We want to rationalize this. Now for this one, you can't just multiply by square root and a square root, okay? You have to think about it a little bit more. So what do we want? Well, this is what we want. We have 1 over fifth root of 3. We want to multiply by some magical factor or a magical 1 so that our result is just 3 on the bottom, or 3 to the power 1. That's what we want. So that way we get rid of the radical symbol. What do you guys think? What is that magical number? One over five, 5 over 1. Be more specific, I'm not sure. Mm-hmm. Right, so this is 3 to the 1/5, right? Good. So what can we multiply by here and here so that when we add their powers, right, we get 1? Because that's what we want right here. So we want 3, right? But we need to figure out what is the exponent. So 4/5, okay, looks reasonable, right? Let's see. So check this out. So I'm going to get rid of these boxes. So we know if we use the exponent 3 to the 4/5, when I add the exponents, I have 3 to the 1. So the magical 1 that goes here is going to be 3 to the 4/5. 3 to the 4/5. Do you guys see that? Let me know if you have questions on this. Okay, and so now that we have figured out the number, we just finish up the calculation. So 1 times that is just 3 to the 4/5 over 3 to the 1. So we have successfully rationalized the denominator. Any questions? Mm-hmm. Okay, let's show that, right? So coming back to this example. So what first thing you want to do is rewrite the radical in exponential form. So rewrite. So we have 1 over 3 to the power 1/5. And we want to multiply by some number so that at the end we have 3 to the 1. Because 3 to the 1 simply means the exponent is not a radical anymore, right? So now we need to figure out what goes here in the blank so that when we combine them with 3 to the 1/2, we get 1. Well, because it's multiplication, I have to use same base. So my base has to be 3. I need to figure out what is the exponent, right? So you kind of have to do guess and check. So you want to figure out what is the exponent so that when you combine it with 1/5, you get 1. So think of it this way. You have 1/5, you're adding some number to it to get 1 as a result. Does that make sense? And then here you can just play around with it. You can subtract 1/5 on both sides. And then your question mark that you're looking for is 1 minus 1/5. And using common denominators, that's 4/5. So that's the exponent that goes here and here. Okay, let's try another one. Let's try another one. So here's another example, rationalize. So say you have 3 over 7th root of 5 square. So I want you to remove the radical from the bottom. So rationalize and then we'll go over it. Question? Right, please mute your audio, that way it doesn't put noise in the background. Okay, someone has their audio on. Please mute it so it doesn't make noise in the background. Okay, so I'm coming back to this problem. Now this one is you want to rewrite it as an exponential form. I think it's easier that way. So let's rewrite. So we have 3 over 5 to the what power? Who can tell me? Right. So now we want to figure out what is this magical 1 so that at the end we only have 5 on the bottom as a result. And then we just figure out what goes on top. So what is that magical number we need? Okay, so 5 to the power of 5 over 7. 5 to the power 5 over 7. Let's check, right? So 2 over 7 plus 5 over 7, that's 7 over 7, that's 1. Check. Success, right? And then we just take care of the top. So that's 3 times 5 to the 5 over 7. And you leave it right there. That's rationalized. Any questions on this? But what we can't multiply them. So it's 3 and 5 over 7, right? So they're two different numbers, right? 5 has an exponent of 5 over 7. 3 has an exponent of 1. It's not really 3 times 5, right? It's 3 times 5 to the 5 over. You got it, right? It's okay. It's okay. Good question, right? Someone else might be wondering it too. So always ask. Don't feel bad. So, right, keep in mind, don't multiply them because they're different. Or if this confuses you, rewrite it this way. 3 and then 7th root of 5 to the 5. And then maybe you wouldn't feel so compelled to multiply them. Maybe, right? Alright, cool. So, let me know if you guys have any question. Alright. Well, that's pretty much it for P4. And the next thing we have is P5. P5 is algebraic expressions. So I won't start P5 today. I'll do that next time. So let me just give you a last minute update before I let you guys go. Still have 10 more minutes, a little bit more. So for now, meaning this week, I don't see you anymore, right? I see you next week. So first thing for next week, we have a quiz. Number 2 on Blackboard, like I mentioned earlier today. And this is going to have P3 and P4, about 3 to 5 questions, but expect 5, right? I wouldn't really go with 3. I'm more going towards 5 questions. And then another thing is WebAssign. Finish up P4. So that's going to be due this weekend on the 13th. Okay, so finish that one. And then you can start moving ahead if you want to, but you're just responsible for P4 up to on September 13. And then last thing I want to give you update on is our first exam. So we're going to have our exam 1, and I'm putting this on schedule for September 23rd. That's a Wednesday. So the exam is only for 1 hour. Okay, and I'll give you more info next week. I haven't thought about what's going to be on it yet. So I'll give you the topic next week, how many questions next week, and to prepare yourself for the exam, you study homework questions. Those are good practice, so make sure you do that. Alright, so this is all I have for you today.
So remember to do the sample test that's on Blackboard. So because we have extra 10 minutes left, I'm here to take any questions if you guys have. If you don't have any questions, you are good to go and you can start doing the sample test. See how Blackboard testing works, be familiar with it, and just keep in mind that